In this video, we'll still be using the Pythagorean Theorem, but this time we're going to use its converse. So let's talk about that real quick. Pythagorean Theorem, if you recall, we'll do it up here in the margin of the page here, says that if I know two sides of a right triangle, then I can easily find the third using this formula. So for example, if I know A and B, their distances, I can plug them in, do a little algebra, and figure out side C, if I know the triangle's right. But a converse means to take the idea that you had and change it up. So notice with the Pythagorean Theorem, I start with the idea that I have this right triangle. And because it's a right triangle, this is true. The converse says just the opposite. The converse says, look, if you've got three numbers that fit, with the two smaller numbers going here, the larger number, the greater value here, if it holds in this formula, then those are the measures of the sides of a right triangle. So the Pythagorean Theorem lets me find a missing side. The converse lets me determine whether or not a triangle, if I know all three sides, is a right triangle or not. So here's what we're going to do. We're going to use this triangle, which hopefully it's somewhat familiar to you. If not, no harm, no foul. We'll work with it. We're going to plug these numbers into the Pythagorean Theorem and see if they work. If they do, hooray, hurrah, it's a right triangle. If it's not, okay, then it's not. So let's try it. We'll take a squared plus b squared equals c squared. And remember, sides A and B have to be the two smaller sides. So in this case, 3 and 4. And it doesn't matter which one we plug in for A and B, just so long as they're the smaller sides. Side C is reserved for what we hope is going to be the hypotenuse, in this case being the longest side. So I'm going to plug it in as 3 squared plus 4 squared is 5 squared. All right, let's see what happens. So 3 times 3, that's 9. 4 times 4, 16. 5 times 5, 25. All right, we're almost there. We'll add 9 and 16. That gets 25 here. Notice that is 25 there, meaning it checks out. Both sides are indeed equal. If that happens, then according to the converse, we have a right triangle. So do the following links here form a right triangle? The answer is an unequivocal yes. Okay, so let's try this one. Now, a quick point of order. Just because I've got whole numbers doesn't mean it's always going to be yes, and just because I have decimals doesn't mean it's always going to be no. All right, so don't let that fool you. We could put whole numbers, for example. If we made this instead of 5, let's make it a 6. Okay, if this was a 6, it wouldn't work, because 3 squared plus 4 squared gets me 25, and 6 squared gives me 36. So just because they're whole numbers doesn't mean it's always going to work. So just something to keep in mind. All right? So let's try this one. Now in this case, we do have decimals, which isn't a big deal. If you have some numbers that you're not sure about, just grab a calculator, plug the values in, and you'll be good to go. So again, we're still dealing with a squared plus b squared is c squared. Remember, c is reserved for the longer side here, so let's write that in. So 12 and 8/10 squared. And then again, it doesn't matter which one here is a or b, just so long as you make one of them a and one of them b. So let's make 12a. We'll square it, and then this 6 and 4/10 we'll make that b. All right. Well, I know what 12 by 12 is. That's 144. I know 6 by 6, but 6.4 squared, now that's a little bit different, 40.96. And then 12 by 12, I know that, but I do not know 12.8. 163.84. Now, take a look. A lot of people are tempted at this point to start adding this side up and trying to figure out you got a decimal, whole number, start adding them together. And that's fine. You can do that. But I want you to notice something. Let's round here for just a minute. This is about 160, right? 160 if we wanted to round, say, to the 10th position here, or 10's position, rather. If I look over here, I'm going to take 140 roughly plus another 40. That's 180. So this is clearly more than what we have here. If we wanted to know specifically, we could type it in. So 144 plus 40 point, what do we got here, 96. And very clearly, we've overshot it. 184.96 does not equal 163.84. Okay, so this is not, so no, this is not a right triangle. What kind of triangle is it? Well, let's think about it. If this were indeed a right triangle, these two squared would equal this one squared. But notice we just showed that these are longer than what they should be. If these sides are longer, not really forming a right angle, and we extend these sides out and make it longer, this angle would have to be smaller. So what we're dealing with here is an acute triangle. Okay? So if sides A and B together, squared rather, end up being longer than side C squared, then what you've got is an acute triangle. Okay? So this isn't a 90-degree angle. This is some angle less than 90. All right, let's try another one. So again, just because we have decimals doesn't mean it's not going to work. It just means we have decimals. So a squared plus b squared is c squared. And remember, c is reserved for the hypotenuse, the longest side. So since 13.6 is the longest side, I'm going to write that in. 13.6 squared. Squared. Helps if you can read it. There we go. Now, let's plug in the other numbers. And again, I'm going to let 12 be a. Oh, not a, 12. Oh, goodness gracious. It's going to be a long day if I'm going to do that. So let's see, 12 squared, there we are, plus 6 4/10 squared. And again, it doesn't matter which one of these is a or b, just as long as your two shorter sides are in there. So again, I have 144 plus 6 4/10. What do you know? 6 4/10. Almost like I managed to make this work out. So 6 4/10, we know what that is. 40.96 equals, now I need 13.6. So let's try that. 13.6, and I'll square that. And according to my handy calculator, that tells me it's going to be 184.96. That number seems familiar. All right, let's add them up. Let's add our 144 and our 40.96. Let's see what we get. What do you know? 184.96. So 184 and 96 hundredths equals 184 and 96 hundredths. So what do you know? It checks out. This is another right triangle. So I can say, yes, answering my original question, do the following links form a right triangle? Yes, it does. Okay. But here's a question, and this will be our last one. What happens when there's no triangle? Notice in this case, they just give me 3 numbers. I don't have a diagram like we did in this third example to look off of. If you don't have a diagram and you want one, draw one. Notice it doesn't have to be perfect. Our two shorter sides need to go on these two short sides, because again, we're not sure if that's a right angle or not. So we'll say 4.4 here, so 4 4/10, and 11.7, so 11 7/10. And then our longest side will go where we think the hypotenuse should be. Again, whether or not it's a right triangle or not, we'll find out. So 12.4. So now that we know that, we can use our Pythagorean theorem again. A squared plus b squared is c squared. I'll let 4.4 be a. I'll let 11 7/10 there be b. And of course our 12 4/10 has to be c. It doesn't get a choice. It's the longest side that we've got. So here we go. Again, if you're not good with squaring numbers like this in your head, not a big deal. 4.4 squared gets us 19 36 hundredths. 11 7/10 squared is 136 89 hundredths. And then of course we'll take that 12.4, square it, 153, and what is that, 76. I was reading it backwards. There we are. Well, let's add them together and see what we get. So let's add our 19 36 hundredths to our 136 and 89 hundredths. I get 156 and 25 hundredths equals 153 and 76 hundredths. Well, that doesn't seem to fly. So if they're not the same, then we have definite answer to our question. This is no. So the question is it an acute triangle or is it obtuse? Well, let's look back. In this one, we said that if a and b are longer, then it's acute. So let's see what we've got here. A squared and b squared added together, what do you know? It just beats it out. So again, an acute triangle. If side C squared is longer, then you'd have an obtuse. So there's the converse of the Pythagorean theorem for you. Again, it lets us see if we have these three numbers, whether or not it's a right triangle. And sometimes we'll get the answer of no, and sometimes we'll get the answer of yes. But the beauty of it is there's only one of two answers. It either will or won't. Again, if you need help, swing by and see me in the mornings. Otherwise, have a good day.